Okay, so in today's video, we are going to look at how to use a factor tree to find the prime factorization of a number. So every composite number can be written or expressed as the product of prime numbers only. So we'll take a look at an example of that and what that looks like. And we can find this by using a factor tree. So for example, with the number 48, we can start to name factor pairs for 48. So for example, I know that 6 times 8 is 48. So if I do a little factor tree here, I have 6 and 8. Those are factors of 48. And then my goal here is to just continue with this process until I'm only left with prime numbers at the end of these branches of our factor tree. So then I'm looking at 6, and I know 2 times 3 equals 6. Now 2 is a prime number, so I'm going to go ahead and circle that. I'm done here. Same with 3. 3 is a prime number, so we can circle that. Okay, then we have 8. Now 8, we could do 2 and 4 as our factors there. And again, 2 is a prime number, but 4, however, is not. So then if we do, again, another factor pair here, we've got 2 and 2. Can circle those because those are also prime numbers. So now we are left with our factors of 2, 3, 2, 2, and 2. Now our writing kind of mechanics for this, we would write out 2 times 2 times 2 times 2, because we have 4 2's, and then times 3. So generally speaking, we're going to write our smallest factors first, and then in progressively larger numbers after that. And then we could rewrite this. So we have 2 times 2 times 2 times 2, which could be simplified to 2 to the 4th power times 3. And that would be our answer here for our prime factorization. Okay, now I do also want to show you that even if you choose different factors to start out, you will get the same answer overall. There is only one prime factorization for every number. So let's take a look again at 48, and if this time we did 2 and 24, we can see already 2 is a prime number. We can circle that. 24, we could do 2 times 12. Again, 2 here is prime. Could do 2 times 6. 2 is prime. And 2 times 3. Those are both prime numbers. So again, our final answer, we have 4 2's and a 3, and that would be 2 to the 4th power times 3, and that is the prime factorization for 48. So our goal is always to list out factor pairs for our numbers until we are ending with prime numbers. Okay, now we can also use these factor trees and prime factorizations for some other analysis, including finding the largest perfect square of a number. So for example, if we were to look at a number like 2000, and we're trying to determine the largest perfect square that's a factor of 2000. That would be a rather time-consuming and difficult process if we were to just try to guess and check or that sort of thing to solve this. But we can actually just use our factor tree and our prime factorization to identify those perfect squares. So I've done a little example here, taking 2000. Now I know a factor pair there would be 210. And then from that, 200 could go into, we could use the factor pair 5 and 40. 40 would be 5 and 8. 2 and 4, down to 2 and 2. Then here with 10, factors 2 and 5. So now we have complete prime factorization. We have 2 times 2 times 2 times 2 times 5 times 5 times 5. So if we wanted to analyze all of the perfect squares that we have here, we can just look at, right, a perfect square is the result of a number being squared, right? So, for example, we've got 2 times 2 here, which would be 4, and that's a perfect square. We also have 5 times 5, which is 25, also a perfect square. Okay, if we were to look at this as well, now 2 times 2 times 2 times 2, right? We've still got, that's 4 times 4, which is 16, also a perfect square. And then we can even do another one if we were to do 2 times 2 times 5, times 2 times 2 times 5, we would have 4 times 5, which is 20, multiplied by 4 times 5, which is 20, for a total of 400. So that is also a perfect square that's a factor of 2,000. Notice, if we were to take 400 and multiply it by our other 5, which we haven't used, we'd have 400 times 5 equals 2,000. So we can confirm that 400 is a factor of 2,000, and in this case, that is our largest perfect square for 2,000.